All right, are there any questions on this slide? Okay, if none, I'm going to clear the ink so we can move on. All right, in the second slide, we guys are going to talk about different types of relation. And for each type of relation, we're going to talk about ordered pairs and some buzzwords here at the bottom, domain and range. Domain and range. So go ahead and copy down your subtitle, 3 types of relations. And the definition of a relation is it is a mapping between 2 sets. It's a mapping or a pairing. A mapping is just a fancy name for pairing. So mapping means pairing. Okay. So you're just pairing up 2 sets. Yes, honey. You copy this too. Thanks for reminding me. And try to leave some space underneath, each red one, because we are going to make some ovals. You remember this from middle school? Do they look familiar? And then we draw some arrows from one to the other. And then we put numbers inside. Okay, so these are called mappings or pairings. Another fancy name that you will see in textbook would be correspondence. So there's a one-to-one pairing. So for example, let's say I put number 2 here and number 5, and I pair each number with another number. Let's say -2 and -5. So I pair them up with the negative counterparts. So this is what we call a one-to-one relation, because every element of the first set or oval is matched with one element of the second oval or the second set. Okay, so now we're going to give them some names so we don't say first oval, second oval, and stuff like that. Let me erase this word over here. So we will call the first one as our input, right? Which is represented by the variable x. And then we call the second set our output, which we will call set y. Okay, so that's a one-to-one relation because every number in our input is matched exactly with one number in our output. So in real life scenario, let's say all of you, right? So every student has a corresponding LAUSD number, right? You have that number assigned to you, the one that has your birth date, and then with the letter and 4 or 3 digits number after. So that's unique for every student. All right, so that's an example of a one-to-one relation. Now let's look at another example of a one-to-many relation. So just by the name itself, it simply means for every one number in the domain, let's say 3, oh no, not domain, but in the input, sorry. I'll use those words later. So for every number in the input, you're pairing it with more than one numbers in the output. So let's say I go 1 and 5, and then I match 3 with these 2. Okay, so that's one number paired with more than one number in the output. So one to many. We can also have, let's say, 6 here. Go, and we pair it with 2 numbers. Let's say 4 and 2. Okay. And I'm just coming up with these numbers randomly. I'm not having any like particular rule in my mind and coming up with those. So those are just random numbers to illustrate relations. So this is an example of a one-to-many because for every one element in our input, there's more than one element in the output. Okay, so go ahead and copy that as I prepare the oval for the last one. Can you think of a real life example of the one-to-many? So for a one-to-many relation, you think of the relationship between a teacher and students, right? So for example, you have one math teacher, that's me, and there's 30 of you right now in our Zoom class. So that's one to many. Okay, what about many to one? Many to one is, let's say, for every student, I don't know how many books you have or how many courses you have. You have 6 courses, right? You have algebra. What else? You have English. What else? You have, um, what else? So this is an example of a one to many also, right? Oh, this is one to many, one to many. Now let's come up with a many to one. For a many to one, let's say we can have, um, you have how many teachers? You have 6 teachers, right? For the different subjects. So you have 3 teachers and all of them, let's say, I'm just gonna put a student. There you go. So you have 6 different teachers. I ran out of space. Yeah, or even more. You have homeroom. If you have sports, you have a coach. There. So that's many teachers to one student. So that's a many to one. Well, this one is a one to many. This is also one to many because there's so many students. Let's say there's 31 now, right? Welcome. Thank you for joining us. All right. So now let's represent that here in our mapping. If you just join us, um, get your notebook and, yep, start to write down your notes. So many to one, let's say 1, 2, 3, and we're just gonna pair that up with one number in the range or output. So there, that's a many to one. Okay, it's a many to one relation. All right, so go ahead and finish copying that. And we're going to discuss those 2 buzzwords at the bottom, which I kept repeating earlier. Okay, so for every type of relation, you can describe its domain and range. Domain and range. Now, these are just fancy words for, you see that one? Input means the same thing as domain. Let me move this on top. Okay. So the domain is just a fancy name for input, while the output, okay, may also be referred to as the range. So domain is the set of all possible input, while range is the set of all possible output. What does that mean, and how do you represent that? So if we go back to each relation that we have, let's say for the one-to-one relation, how do we write down the domain? So the domain is actually written as a list of all the numbers. A list of all the numbers. You start with a curly brace. So you see the curly brace right there. Okay. Um, so domain, and then you put that curly brace like that. If you're typing, that's going to be next to the letter P on your keyboard, I think. Yeah. Okay, so now let's list down the possible input values. So what are the numbers in the input of these one-to-one relation? So just look at the 2 numbers inside your oval. They are 2, and then separate them with a comma, 5. That's it. Why? Because they are the only 2 under the input column, right? Now similarly, you do the range, okay? You make your curly brace again. Now you look at the Y column because the range is from the output, and then you list them down, -2, comma, -5. Is there any particular way of listing them down? No, but I would just let's say maybe follow their order so I don't miss out any number, right? Okay, so that's how you write down the domain and range. So I'm gonna wait for you to try this in the chat, and you can also try that on your notes. So can you give me the domain of these next 2 examples? Can you give me the domain of these next 2 examples? You can type in the chat or unmute yourself so you can tell me what the numbers are at or what the numbers are. Okay. Anybody? I think it's faster if you unmute yourself, right? And just tell me what the numbers are for the domain of the one to many. Domain for Anna said 3 and 6. That's great, honey. For range, 1542. That's great. So you can list them down in any order if you want to arrange them. You can also do that. Thank you, Anna. Next, for the many to one relation, what's a domain and what's the range? For the many to one relation, what are the numbers in the domain and what's that single number in the range? Anybody? The domain, Anna said, is 1, 2, and 3. That's great. And the range, there's only one number in the range, which is 0, right? Very good, Shalia. Okay, so what will happen if a number is repeated? So let's say if you look at this one, 6 was used twice, but Anna did not repeat it 2 times in the domain. So if a number is repeated, like in a one to many, you don't have to write it 2 times. You don't have to say 3, 3, 6, 6. So all you need to do is write it once. Okay? All right, so go ahead and finish your notes on that one before I move on to the next slide. I'm taking a picture. Okay, we're moving on. Now let's move on to the third slide. Okay, I'm going to give you some time to jot the following down. You need to copy the definition of a function. There you go. So copy the ones that I put a star at and this one also. Those are the only things you need to copy. Yeah, but not the whole diagram. So just write down the definition of a function and this paragraph over here. Okay. Oh, sorry. Maybe my internet was choppy. Yeah. So just copy the ones that have stars. So this one, a function is a relation, and then this paragraph over here, the green one. Yeah? I hope you heard me this time. If you guys texted me your notes last week, I I have them on my phone and I did screenshot them. I have to update your Schoology, if not today, tomorrow. My light days are Wednesday, Friday. So if you're wondering, you know, when your paper or your grade's gonna be updated, I normally do it on Wednesdays and Fridays because I don't have a first period class, or I don't have a period two. That's my conference period. Is Anthony Paiva here today? Nope. Okay. Giselle Guzman. Guzman. Hi, Stefano. For some reason, Stefano, you were not marked present in period one, so communicate with your teacher if you were marked wrongly, okay? All right, I hope I gave you enough time to copy that while I check your attendance. Okay, so let's see. The first one that I asked you to copy is the definition of a function. So in the previous slide, we talked about three relations, right? But not all three relations can be considered as functions. Okay, so which of those three relations can be considered functions? And how do we know? According to the definition here, a function is a relation where every input has exactly one output. So in other words, no input is repeated. Okay, so what do I mean by that? No x value must show twice as an x value. So no x value um, must repeat. Okay, it doesn't mean it cannot be repeated as an output. Okay, but it cannot repeat as an input. What do I mean by that? Let's say, for example, two repeated, right? But that's an input, that's an output, that's okay. So if, let's say, this is 3 comma 2, if you look at the two x values, they're different, right? 2 did not repeat as an x, 3 did not repeat as an x, so this is a function. So in this case, this is a function. All right, but if you have something like 3, 5, and 3, 6, oh, look at that. This is an x, this is also an x. So a function or a relation becomes a function when no x value is repeating. So if you repeat 3 as an x, then this is not a function. So if it's not a function, we only call it a relation. Okay, so that means among the three relations that we talked about earlier, the only functions are, so let's write it down, the relations that are functions, okay, there are also functions, are one to one, and many to one. So those are the only relations that do not repeat the x value as an input. Okay, so going back to my example here, 3 goes to 5, and 3 also goes to 6. So that's a 1 number to 5 and 6. So 1 is to many. So if it's a 1 to many relation, then it is not a function. Okay, so that's how you can spot whether something is a relation or a function by looking at the numbers, okay, whether they are repeated or not. However, there are instances when you see some graphs. So I'm going to go here now. So previously, you've seen this graph in middle school, right? You've also seen something like maybe a sideways curve like this. You've also seen, circles like that were graphed. It doesn't look like a circle, but yeah, I tried my best. So how can you tell whether a graph is a function or not? You are going to use what we call a vertical line test, and it's said right here, right? So vertical line test. So what does the vertical line mean? So it means that if you can draw even just one vertical line that touches your graph more than once, then it's not a function. It's not a function. So if you're going to cross a graph, you're going to cross it only once. Let me show you how. So let's say I make a vertical line here. Does it matter where? No, it doesn't matter. It even doesn't matter like how many lines you're going to make. So that's 2 lines, right? Okay, so you're going to write as many lines as you want. But if each line crosses your graph only once, okay, then this is a function. Okay? But if you look at this graph, one ruins it for all. So one line crossing your graph 2 times, then you don't have to check anymore, the other locations for the line. So this is not a function. So if it's not a function, you only call it a relation. Now, in case of the circle, again, just one violation ruins it for everything. So you don't have to make a lot of lines. If you can find just one line that crosses your circle 2 times, then this automatically will not become a function. It will just become a relation. All right. Okie dokie. So on this slide, we talked about when does a relation become a function and how you can check ordered pairs like this and graphs like this if they are, relations or functions by looking at the input numbers repeating or not repeating and whether the vertical line crosses the graph once or more than, or, once only or twice or more. All right, so go ahead and finish your notes on that one. You got one last notes to write and you'll be done with the notes. You're just going to be practicing after. Okay, I'm going to clear the ink when you're done. Okay, here we go. So last but not the least, I'm going to skip this one because I already talked to you about that. Let's do this. Okay. So when you copy this graph, write down the title, discrete versus continuous. When you copy this graph, you don't have to copy the lines. Just make an XY axis like this and then try to put the graphs, the points like randomly like this. We don't need the actual numbers, but maybe just copy how it looks like. You don't have to put the little grids. Okay. All right, so go ahead and copy those graphs. We're going to discuss those and write down our notes, and we'll do some examples after. Okay, so you've seen something like this in middle school. You know what this is called? It's called a scatter plot. because the dots are scattered in no particular order. They're just randomly placed, right? And they don't follow a certain shape, they don't follow a certain graph. So if the points are scattered, then you call that graph discrete. Discrete. So a discrete graph has separate or distinct points. They don't follow a certain pattern. On the other hand, if you see a straight line like this, okay, so this is a trend line or a linear graph as they call it. Okay, but I would call it a trend line because it doesn't have y equal to something yet. So you call that a continuous graph. Why? Because all the points are connected. All the points are connected. Mhm. All right. So those are examples, or that's a difference between discrete and continuous. So when we look at a word problem, next meeting, we will decide whether we will leave the points separated or we will connect them with a line. Okay? So for today, pretty much we're just defining all the terms that we will use. All right. So those are your notes for today, but keep your notebook open because we're going to practice. I'm going to close this and be ready to type in the chat or unmute yourself because we are going to answer some slides here. We're going to skip slide number 6, okay? Oh, okay. Yeah. Sorry. So we're going to skip slide number 6. Oh, I miss doing foldables and graphic organizers in the classroom. Okay. So when you're ready, I'm going to go to slide 7. Okay. I'll wait for your answers in the chat or unmute yourself. Here we go. You will type either relation or function. That's all you're typing. Relation or function. Remember again how to figure out whether it's a relation or function. If the x number is repeated, you say it's a relation. But if no x numbers repeating, then it's a function. Okay? Let's try. Letter A. Letter A. What do you think is that? Relation or function? So look at the first numbers. Ignore the second numbers this time. Remember, an x may repeat as a y. That's okay. It's still a function. But if the x becomes another x in a different ordered pair, then that's a relation. Okay? So what do you guys think? The number here is -2, -1, 0, 1, 2. Okay, are any of those underlying numbers repeated as first numbers or as an input? So think about it again. So what I was trying to explain earlier was if you see 2 repeated here, that's okay because 2 is x, while in the third order pair 2 is a y. So 2 may repeat as a y. It's also y in the first one. So as long as you don't see it as x in another ordered pair, that's okay. Right? So Emily said relation. What do you guys think? What do you guys think? In letter A, is it only a relation? -2 was not repeated in the first spot. -1 wasn't repeated either. 0, no, it did not repeat as an x. 1 did not repeat as an x. 2 did not repeat as an x. So letter A must be a function. Yeah? Okay. Next, letter B. Look at letter B. Look at the first numbers. 4, 8, 6, 4, 5, So what do you think about that? What number did I say twice? What number did I say twice? And if a number repeats, then what is it? Is it a relation or a function? Anyone? Zayden said it's a relation. Very good, Zayden, because 4 was repeated, right? That's awesome. Okay, next. Yep, you repeat 4. Very good, Samantha. Let's go to letter C. You look at the input. You look at the X numbers. So what do you call letter C? Relation or function? I don't know how many of you are actually looking at your screens. This would be one of those moments when I would really love you to show your cameras. But yeah, okay, so letter C. Letter C, anybody? Function, according to Shalia. What do the others say? Okay, so let's analyze if it's a function or a relation. -2 did not repeat. -1 did not repeat as an x. Oh, look at this. 0 appeared twice as an x. And one violation ruins it for all. So if 0 is repeated as an x number, then if 0 is repeated as an x number, oh, Christopher, what was that? So if 0 repeats as an x number, then this must be a relation only. There you go. Relation only. You okay, Christopher? You fell asleep on the keyboard, huh? Okay. All right. So relation because 0 repeated 2 times. Yeah? Okay, then maybe you're wondering, but miss, what about in letter A? You said it's a function. But I also saw zeros. Okay, remember, 0 here is in the x. It's in the x position. While the other zeros are y's. They are not x values. So if they repeat on the y, that's okay. But if they repeat on the x or as an input, it's not okay. Letter D. Letter D. Anybody? Letter D. Function, according to Zayden. Yes, that's correct. And Emily said function as well. Because you have -1, 3, 11, right? Very good. And this is many to one. So many numbers to just one output. Very good, Zayden and Emily. Okay, let's try another one before we go. This is almost the same, so I'm gonna skip that. Let's go to slide 9 instead. Here we go. You're gonna tell whether it's a relation or a function. So remember your rule, your vertical rule. The fastest way is you put a finger on the screen, you know? If your vertical line, okay, just put the finger next to your screen. If your finger crosses, the graph only once, then it's a function. I hope you're not popping your middle finger right there. So, yeah. So if you draw a vertical line and your vertical line is only passing through the graph once, then it's a function. So what do you think is number 1? What do you think is number 1? Is it a relation or a function? If you make a vertical line and it doesn't matter where, how many points does it cross? That's just 1 point. Maybe here, there. Okay, that's also crossing it at one point only. So if any vertical line passes your graph at exactly one point, then what is it? What is it? It's a, what do you think? Relation or function? Relation? Oh, but like we we're touching only one point every time we draw a vertical line. So it must be a, yeah, it must be a function. It must be a function when your vertical line, passes one point at a time. One point at a time. Yeah. What about number two? I know, like, it's this lesson seems so simple, but I'm taking time on this one because it's, I don't know, it creates the most confusion, you know, um, among students when it comes to linear functions. And this concept is really important all the way until you get to algebra 2. So if I make a vertical line over here, I'm touching the graph only once. If I make a vertical line here, that's one point right there. If I make a vertical line here, that's one point right there. So every vertical line touches your graph at only one point. So what is that? What is that? It is a, anybody? It's a, it's a function. Very good, Evelyn. So number two is a function. Ooh, look at number three now. If I make a line here, look at that. I cross it once, I cross it twice. And even if I make one here, I cross it once and another time. And here, I cross it once. That's a relation. Very good, Emily. And yay, you're getting it now? Okay. And the last one. If I make a line here, that's one. If I make a line in the middle, that's just one touch right there. If I make a line here, that's also one point. It's a function. There you go. All right. So if every line crosses the graph once, then it's a function. All right. Okay. So um, I hope you guys learn your new vocabulary words for today. And for your independent work later, after school, or maybe while you're having lunch, you can also work on it. In this folder, in the same folder, you don't see the piggy bank yet. We'll do that next time. You will just practice on this one, 3.1 functions. Okay, so this will be your independent work for today. So if I could put it up so you can see what's on it, you guys will use all the terms that we learned today. Let's go preview. All right, so you are going to use like a drop down, you know, um, and tell whether it's a relation only or a function. Okay, so that's the thing you guys will do. And that's all the way until, yeah. Okay, so you're going to pick whether it's a relation or a function. All right, but why did it say only 4 points? It has 10, so let me edit that one. So this should be 10 points. Okay, so today is the 13th. Enable submissions. Exposure. All right, you guys. So that's what you will do today after school. If you have no more questions, then I will see you all on Friday. No, Thursday, right? Thursday. All right. Okay, bye everybody. You guys have a good day. Be safe and regards. Bye.
Bye.
Bye. Bye. See ya. You're welcome, honey.